Alrighty, so I guess I'm gonna read this off here before each. So you can take off your mask if you're socially distanced and seated. If you are walking around, please put your mask back on. I will read my bio in here, and yeah, awesome. So thank you everyone for joining today. Before I begin, I do want to say thank you to Palmera Media Group, Ettore, for the invitation to speak and present to you. So glad to get back to doing these things live. I hope everyone's really having a good time. For those of you who don't know me, my name is Minh Tran. I'm a dental technician based out of Windsor, Ontario, which is about 4 hours south of here. Been in the industry since 2006, and in that time I've had the luxury of working behind the computer with a mouse and keyboard, primarily with 3shape, but also with a wide variety of both digital and traditional technology. And in my spare time, I run a blog called Dental Tech Tips, where we focus on the latest and greatest in dental technology. So if you want to find me online or via social media, you can find me in all the usual places by liking at Dental Tech Tips. So today we're going to be speaking about copying and pasting. It's a relatively simple concept. I mean, everyone is hopefully familiar with this, and how we're going to use this concept to really help us with taking on and tackling complex digital workflows. So copying and pasting is essentially you have a source, some kind of item that you want to take from one spot and you want to drop it into another. So usually when I teach any type of course, or a lot of the time in the past recent years where we've moved a lot of it online, I end up copying and pasting this slide here onto a lot of my presentations, and I kind of focus on this part right here. And 3shape, a wax knife, a hand piece, pretty much everything that you use is just a tool to help us to really facilitate our work and in order to produce the products that we need to produce. So in order to really get to master your tools, like people who are ceramists who really know how to work with their brushes, you've mastered that tool. With a hand piece, you know how to stabilize yourself in order to really use that. So just like that, with a mouse and keyboard with 3shape, you really need to understand and master that tool to make the most effective use of it. So of course we're going to be speaking about, there we go, this little analogy that I like to put up there. It's a fun little challenge here. So thinking outside the box. The challenge here is relatively simple. If you had a pen and paper, you'd have these 9 dots up there, and you would try to connect these using only 4 straight lines without lifting the pencil off of the paper. Seems simple enough. Let's see if we can try and do that. So 1, 2, 3, and 4. So I guess we missed that 1 dot. Okay, let's try this again. 1, 2, 3, almost. Okay, I'm going to try one more time. This time I think I got a different strategy. Maybe we'll get it this time. 1, we're going to cross across, up, and it was worse, right? We missed 2. And let's try one more. 1, 2, 3, 4. Still can't get it. I'm sure a lot of you have seen maybe this puzzle online, but the solution is pretty simple once you see it. And when you actually think literally outside of the box, you're able to connect this with 4 straight lines without lifting the pencil off. So the whole point of this is to kind of demonstrate how you kind of have to use this out of the box thinking when working with a program like 3shape. So of course some prerequisite understanding that you want to take when working with complex workflows with 3shape. You want to have at least some basic level of computer literacy, understanding the file system, how to move folders and structures and renaming things, and just a general idea of how a computer works. And if you don't know how to do this, I recommend at least taking some kind of computer literacy course online. You can find them online. And maybe even moving on to a computer programming course, not necessarily to learn the language, but at least to understand some of the concepts there that are really handy in understanding the fundamentals of 3shape as a program and how it works. So of course 3shape is this massive program with all these sub-programs, all these materials, resources, indications, and it's really kind of overwhelming to wrap your head around the concepts and everything there. Right? You have Model Builder, Scan It this, Control Panel that, they have annual releases, different updates. So trying to wrap your head around that, it may not be very apparent if you're just kind of jumping into it. But what I like to do is, again, going back to fundamentals, we'll take a quick step backwards to basic grade 10 algebra. I was very fortunate to have a very good math teacher back then, and he taught me this concept about variables, and this is like one of the core fundamentals. And his analogy was that a variable is a container, but I'll start here with this equation. You'll see x equals 1. So the variable, and then you have a value. So x is the container, 1 is the value. And a lot of people kind of get hung up on the letter x. They think, okay, well, pi is 3.14, and e equals mc squared, and all these kind of cliche type of mathematical constants. But you don't need to worry about memorizing what the value is. These things fluctuate. That's why it's called a variable. And very much so, if x could equal 5,422. But the way that he kind of framed it for us to understand it was that x is just a placeholder. It doesn't need to be x. It could also be truck, and truck could equal 1. But truck could also, the truck contains 1 box from Amazon, or the truck could also contain 5,422 boxes from Amazon. So it's a container that holds some kind of value. So when we take this understanding, when we move that into 3shape, 3shape itself is a program, it's a container. It needs data to be put in, it needs values. But we can also look at all these sub-items, so like a DCM file is also a variable. It's also a container. And inside of that DCM, you have either a tooth, full arch maxillary scan, you can have complete dentures inside that DCM, or you can even put a truck inside of that DCM. Let's move on next to another fundamental subject, and that's geometry and 3D Euclidean space. Very often you see these in programs, and it's the XYZ symbol, it's an axis or an origin, and it denotes the how you map things in 3D Euclidean space. So our CAD/CAM programs use it, CNC machines use XYZ coordinates in Euclidean space to map these things out. 3D printers, same thing. And essentially when you're scanning something, what the software is doing is the scanner is taking a bunch of little tiny dots. It's called an XML point cloud. And with these dots, it's connecting them together to make a blanket or like a mesh of that data. And that's how we get the object displayed on screen. So with that, we're able to make a crown over it, make an appliance, make whatever. And each one of these items has its own set of unique XYZ coordinate data in Euclidean space. Something to keep in mind for some of the subsequent things we'll be talking about. So of course, you take that XYZ data, you feed it into a CAM software, you can feed it into a 3D slicer. They analyze the geometry, and they spit out all these little numbers that allow you to press a button, mill something, or print something, and 20 minutes later, you have your object. So we have our prerequisites here: computer literacy, file manipulation, understanding the operating system, understanding variables, just containers that hold data, and of course, understanding that XYZ coordinates in 3-dimensional space and that they're all kind of unique, and we want these things, and this is how we get our data out. So how do we put this all together to make digital full mouth complex cases and rehabs using 3shape? Well, what I like to do is I always like to take a facially driven, prosthetic minded approach whenever working with anything, especially for these complex cases. So very much so, if you saw my presentation earlier today, then you would have seen this case. This is Jenny. We did a case for her, full mouth rehab. And we start always with a smile design. And the reason we do that is it's a very simple way to just get a starting point for where you want to start. So we use this 2D smile design that's patient excitement and kind of as a roadmap for what our ideal endpoint is going to be. Then what I'll do is I'll pair that with a 3D digital diagnostic. And the thing that I like a lot about these 3D digital diagnostics is it allows me to play, it allows me to really see what the final product will be, where we may need some prosthetic reductions, where we may need to use crown lengthening, for example, orthodontics, whatever else. So that allows us to take a very multidisciplinary approach to these things. So what I'll do is I'll take this 3D diagnostic and then I'll pull it. So when you do these diagnostics in 3shape, you want to create an order form. You want to choose an object, and you want to choose digital impression up here. It's a little bit blurry. And then what you're going to do, if you choose model, it won't allow you to choose this item here, which will allow you to build a model. And again, going back to variables, don't get hung up on the word object type and that it's a digital impression. If you scan this with a desktop scanner, still set it to digital impression because it's just a name and it's just a container. So for example, it could be called monkey for all we care, and this could be a banana. If the monkey wants a banana, we give it a banana, or we give it something that's fake that looks like a banana, and it'll allow it to pass, right? So in our case, we set it to digital impression, and then of course we have our ability to build a a model here. Next, of course, we're going to select all the teeth here. I'm going to choose temporary unprepared model. Again, don't get hung up on the name. That's just the indication that I use here, and I'll explain why in just a moment. We're going to bridge all of these together, select digital impression, and then select model. And that's how we set up the order form in order to do a 3D digital diagnostic. We hit OK, import our scans. If you already scanned it in, it might ask you if you want to re-import scans or rescan. Just say no. And then we just go through. I'm just going to mark the model really quickly, do our annotations. And the reason I bridge it all together is it allows me to only set one insertion direction. Again, this is just like you're setting up Pontics. You're doing it's not something that you need to worry about directions. You don't need to worry about margin lines, cement gap, anything like that. The temporary and prepared model indication allows me to focus on the aesthetic concerns, prosthetic concerns, opening the video, making sure that I get a nice result, rather than focusing on, oh, well, you know what, the left facet error on this margin, or there's an invalid boundary. Temporary and prepared model allows me to really go through this design in no time at all, and I have a diagnostic that I'm very happy with. I remember doing these by hand, and I'm showing you what I thought at the time was really good, but looking at it now, it's pretty awful. But doing these by hand, you get really invested in the amount of time you've spent on it. Maybe I made that distal line angle a certain way, not necessarily because it looked good, but because I invested the time in it. And I don't carve that away, and I just keep that, and I kind of make the other side symmetrical. So it's so much emotional and time investment in that. Whereas with digital, if I don't like it, I just cut it off, sculpt it 15 different ways, and if I didn't like where it went, I just hit undo, go back 15 steps, and there we go, we're back to where we were. So of course, we bring this into Model Builder, and you just attach the files very quickly, and then it'll append everything there. You can also sculpt these and make sure it's all nice and smooth. But you get a very nice 3D digital diagnostic model that you can, of course, at that point print off, and we produce the models for a composite mock-up intraorally that we can use kind of as our roadmap for the rest of our treatment. So then, of course, now once we did that, the doctor would make a temp in the mouth, take an impression, and we want to make these a second set of temps, I believe this was. But if you were doing the final definitive restoration, you get this, and if you didn't know what we're going to teach you today, maybe you use this blue scan and you're making these kind of sad, wrinkly copies of your pre-prep, and then maybe you carve some chicken scratch in here to try and make it look presentable. And it's not really great. It doesn't look really that good. And you say, you know what, maybe I'll just finish a little bit in the green stage before I sinter it. And it's a big waste of time. It probably takes a good, for a full mouth like this, 2 hours, even though you have the pre-prep to sculpt all this stuff. And it just doesn't look very good. It's not the best product. It's not what you had initially waxed up. But maybe there were some changes in there. Maybe there were some changes in inclusion that you need to dial in. So what we're going to show you today is how we're going to copy and paste our original designs into this. So number one, you're not making these sad copies. And number two, it's a much faster, more efficient way of doing these things. So work smarter, not harder. So what the concepts that we're going to go over are, of course, anatomy for reuse, dummy orders, autocorrect, file manipulation using Windows Explorer as well. So when you finish your diagnostic model, you want to look inside this Windows folder here. And you do that by right-clicking Explorer, and it'll bring you to this folder here. And the first folder that you're going to see here is this anatomy elements folder. So what this contains is a whole bunch of Pontics of the original design that you made in your diagnostic, lined up in coordination with the original pre-prep scan. And they're all there, they're all in alignment. Keep this in mind, this is a very important folder, especially for these copy and paste type of workflows. And then of course you have, next is a backup folder, don't worry about that too much. Then you have your CAD folder. This is a very important folder as well, especially for some of these workflows, because it contains the actual finished CAD files. And a very quick dental tech tip here is if you ever have a problem generating CAM, just go ahead, convert these files. They'll convert it to an STL, and you can grab these, bring them in. The only caveat is, of course, that it won't be in alignment, but most CAD software, most nesting software will allow you to place these and rotate them in proper orientation. So if you ever need to, you can grab those files from there as well and use those. So that was just a little segue there. But going back to it, that's my dental tech tip for the day. And then, so of course, the next one is your scans folder. There was a couple other folders here. External models. These are the Pontic files, not in alignment. These are just the ones that you used in the library before they were modified. Feature cache is where the software, like all your mouse clicks are stored. So this allows you to redesign it really quickly if you need to. And then scans, that's another important folder where you need to kind of focus. So if you need to rename or move things around, we'll kind of show that as well. The last thing that the only other one that I really focus on is materials.xml. This one is not really important in most workflows, but primarily with implants. If you need to modify some kind of values inside of material.xml to allow that implant to proceed and generate a CAM, sometimes you need to modify this file. So we have our final definitive impressions, and you can also see the doctor here also give us a scan of those temporaries in the mouth. So what do we do at this point? So I'll check the order form, import it, make sure everything is good. All my indications are set up properly so that I'm able to proceed and make sure everything is set up the way I want to. And then what I'm going to do is I'm going to create a dummy order. So this dummy order, you don't really need to worry about it too much. We just go new, go here, and we'll just set it again as a single unit temporary unprepared model. I didn't think I had music in mind, but yeah, so is it going to play? There we go. So we set our order form, set it as a single unit temporary unprepared model. And the reason, again, that I set just a single unit here is because we don't really care what the indication is. We just want to put some data in there, use this order form, and get that data out. So as I said before, if you look here, the scans, the initial pre-prep scans and the diagnostic that we made, they were in a specific orientation. And then, of course, the diagnostic that we make over top of it is also aligned to that. It's in that orientation there. But the new scan, you can see here, is not aligned. It's misaligned here. So what we want to do is, if we want to copy and paste our design and make it the most efficient, we needed to make a way for these to all align and correspond with each other. So what we do is we open up that dummy scan, import our original order, or import our original order scans at least. Import the upper, import the lower. I'll skip past this. And then what we're going to do is we're going to import our pre-prep scans, or our final scans as well. And what we're going to focus here now is on the additional scans tool. So this is probably one of my favorite tools in recent years from 3shape, because what it allows you to do is it allows you to just bring in whatever objects you want, align them all together using this alignment tab here, and then you can also save them. So I'm going to bring in my new scan from the doctor. And then, let's see here, where is it? There we go. And then we use the alignment tools. So you mark these. And if you have like a full prep, these ones we happen to have to keep these ones to maintain the vertical dimension. But if you have a fully prepped, you can also use palatal landmarks. Not extremely accurate, but it does help, and you can always tweak it with the move tool at the end. Make sure everything is in alignment. I'm sorry, the video is not working for some reason. Align these two together. Make sure we're happy with the alignment of the upper. Same thing with the lower. And then what we do is we move on to the Save Scans tool. I'll skip over that. We see these are in alignment now. We're happy with where everything's kind of ended up. So we go here, save. We check this little box here that allows us to save that additional information, which is the new alignment. and then we go ahead and file dialog will come in here, and you just save it as an easily recognizable name. I use the same name as the patient, and then just aligned, and then that's how I know. And then we make another order, go back, reset our one order here, import the newly aligned scans into proper alignment, and then we're also going to grab our anatomy elements folder that I was telling you about earlier. We're going to go here, right click, advanced, explore, and then we're going to right click, paste our new folder, and we're going to rename it anatomy for reuse. If you can't see it here, I apologize. It should be a little bit higher resolution, but it's not. But it's anatomy for reuse. And what this does is it tells the software that we want to reuse our old design in alignment and everything like that. I don't have a design video of this, but I kind of have a quick summary of it. But basically, you bring it in, mark your margins, and at this point here, and when you get to the design phase, it'll bring up your anatomy for use, and this is the final finished product here. But essentially, it makes very short work of this. You've already done the design. Maybe the final design will take you another 20 minutes. And this is the finished product for that case there. So yes, please be lazy when it comes to these large cases. It makes it, number one, a lot more efficient, but it also makes it a lot more predictable and effective results at the end. So let's explore a few of the other ways I kind of use this methodology in tackling some of these larger cases. So this one here, we had a case here that we determined the patient needed some kind of crown lengthening. So what I'll do here is I'll do an initial 2D smile design again. I'll do a 3D digital diagnostic. And then what I'll do, if they approve of that, is we'll bring it in as tampon prep once again. And I'll just plain cut these straight across. What I used to do is I used to make these out of the custom tray module, but I wasn't very happy with the way the margins and the finish line around these windows, they weren't very precise. So what I do now is I'll cut these straight across, and then we'll just have the cervical 1/3 left, and we'll make like a clear suck down that the periodontist can use to follow and do a reduction, like a perio guide there. So then of course also once we do that, patient went through the crown lengthening process, they're healed up really nicely. So what I do is, again, I take my design, I bring it back into dental system, and then I make prep guides. So these are 3D printed preparation guides that we make for the doctor. You can use these to check all these. And again, I'm just copying and pasting my previous design, and I look like a superstar to the doctor. His job becomes a lot easier. I get a lot of nice interproximal clearance, incisal, everything like that. And of course, we have our final result, which is very close to what we had initially determined. Another really cool thing that we're using is for anatomy reuse specifically is this hybrid bar case here. So again, we set it up as a diagnostic tampon prepared model. And what I do is I just go ahead, create this order, set it up, and I have a really, and if you look at the indication here, you can see tooth number 18 is included. And what I set there is I just made it a really big, and I have a library file there for a pontic, basically, and for gingiva. So rather than setting up as gingiva and having it tell you, oh, there's a hole here or there's an error there, you just set it up as a really big pontic. Tampon prep doesn't care. You just set it up, put it there, and it's all nice and connected. Again, I did this design probably in about 20 minutes. And we send this off to the doctor. We punch some holes, and he can realign it in the mouth with some temp cylinders. And you can use this for the patient long term while we're kind of dialing the bite and doing the final definitive. Meanwhile, I mill a bar once we verify everything. So we do a titanium bar, mill this out, and we're going to make a little zirconia sleeve over top of this. So once again, do I go through and try like a barbarian and start from scratch? Of course not. But I take my initial design. If there was any kind of modifications, then we'll do it then. But I have a question for you. So we're trying to make a sleeve, so a hybrid zirconia over titanium sleeve that'll fit over this bar. What indication do you think we can use to make, number one, an intimate fitting sleeve that is also machinable on the intaglio surface, but also incorporating the anatomy for use? Anybody? You're right, actually. So one of my first inclinations when I tried to kind of experiment with this first was to use tabletops. But the problem with tabletops is it doesn't allow you to select the whole bar. It has a kind of a volume limitation. But very much, yeah. So the first indication that was ever available to 3shape was the coping indication. So what I call this is the 3shape big coping workflow. And basically, we're really just taking advantage of, again, the containers, the variables, and just that it doesn't matter that we're setting it up as a coping, just understanding that the software needs some information in, and as long as we're providing that information to 3shape, it'll let it pass. It's like a bouncer at a club, right? You give it a fake ID and he'll let you in. So, of course, all that it cares about is the rules set for that indication. So we use the big coping workflow, and what I do here is I'll make a new order, set number 17 as my coping, and then I'll set number 16 as a anatomical pontic and bridge these two together. Import my scans. Paste my anatomy for reuse. And I'll name it UNN3.DCM. We're going to mark our margin, make sure it's segmented properly. Mark our annotations. And we'll go through, mark our margin, make sure everything is nice and good. High water design here. A little bit of pressure on the tissue. And you can see here it accounts for undercuts. And at this step right here, you have your die spacer, you have your burr compensation. And it's very nice because this will give you a very intimate fitting bar and a machinable fit surface. So now we go here, there's my anatomy for reuse, and we're going to click on that. And we just want to make sure that that file's there. That's what it looked like, my little design here. And we're going to load it in. Well, we're going to attempt to. You can see here we can click a whole bunch of different ones. But this one here that says anatomy for reuse, we'll click it and, uh-oh, what happened here? No, so there was an error. Can anyone tell me what we did with the software to make it so angry? So again, going back to my my analogy there, we need to supply some kind of information to the software that it's looking for, so it'll pass, right? So I said, oh, maybe it's corrupted. So we'll test it. I'll grab a different file. I'll rename it UNN3. We click on it. It loads in just fine, right? So we kind of have to compare and figure out what's different between these files and what we need to do in order to get the software to go past this error. So what do? Well, a magician doesn't give away all of his tricks and secrets. I have a folder here called Hollywood Magic, and basically some Hollywood magic does have to happen. If you're interested in doing any of these kind of what I call laundering the DCM file, I will be holding a 2-day hands-on live course where we'll kind of show you how to do this. So if you're interested, dentaltechtips@gmail.com, send me an email, send me a message online via DM, and we can show you how to do that. But basically Hollywood magic happens. We grab this file, you go in here, UNN3.DCM, we select our anatomy for use file, and hey, look at that. It works just fine. So now we go through, and we need to go to the next step, and it is protruding through the bottom of that, so we will have to sculpt these away. It is a little bit tedious, but it does make it very predictable. So we go through and just reduce underneath so it's not poking through that coping there, the intaglio fit surface. Clean it up really quick. Because it's an anatomical pontic, we had to set it back to 0, remove the connectors, make sure everything's good, smooth out all of our lines. Usually you bring in your original scan with the holes, but then you can use the parametric cylinder hole tool to place all of your cylinder holes really quickly. Apply those holes, and then now you have a machinable zirconia sleeve that'll fit right over. The nice thing as well is with the coping, you're able to set a 2 millimeter minimum thickness, so you know that you have enough material thickness for this specific case. So you send it off to the mill and off you go. And then we grab these files, bring it in. I like to do like a printed sleeve prototype. Did I do that? No, not this one, okay. So yeah, thinking outside of the box, another example, of course, is adding a third bicuspid. So this is, again, using the additional scans tool, using the morph tool. So typically when you do like a large full mouth design like this, sometimes there's just too much space here and you need to add a third bicuspid. So what do? Do you close the order, reset number 4.6 and 4.7 and make that 4.7, 4.8, add another one in here and introduce some chaos in our lives and we lose 2 hours of design? Of course not. What we do is we just grab this tooth here, move it over, bring up the additional scans tool, go here, control click, select both, keep additional information, save this. I have a temporary folder, I name it 1.dcm. Bring this back and control Z, load that file back in. And you can see here that it's there. And I made a little mistake here. I forgot to correlate the model with the lower. It's still set to upper arch here, so I'm trying to click and it's not really working. So you go back into the, once I kind of figure out that I made that mistake, I go back here. To the additional scans tool where we end up correlating it to the proper arch. So I set it 1.dcm correlates with the lower arch. Now we click it and it doesn't give you, again, it's kind of that sad, kind of wrinkly copy of the pre-prep, but this beats going back and doing 2 hours of redesign to add a premolar, right? So we make this copy, it'll morph to it. We have to clean up the embrasures a little bit. Maybe we need to carve the anatomy a little bit more, rotate things around a bit. Bring these down, make sure it's nice and intimate with the tissue. But it makes very short work of something that could have, really ruined your day. And of course we connect all this together, make sure everything looks nice and hygienic. And that's our final result there. So I'm gonna kind of shift gears a little bit and move on to digital dentures. So that's one of my latest initiatives is really to kind of ramp up digital dentures. The number one, because setting up a digital denture is much better than doing it by hand, in my opinion. You can choose from bilaterally balanced occlusion, lingualized occlusion, and it's set up and you can focus on it and you don't have to worry about waxing it up. So there's lots of benefits to doing them digitally. And you can also do them in a very non-destructive manner, right? So if the patient's dog swallows their denture, let's say, you can just reprint a new one or remill them a new one. So there's plenty of benefits to that. There are a couple of limitations to the denture design, though. So one of the scenarios that we may have is the patient likes their denture very much, and we're going to cover that in a moment, but they want to replace those teeth. So one of the modules that I use for that, of course, is the Copy Denture module, which was introduced in 2019 by 3shape. And it's one of my favorite modules because previously with 3shape, the only thing you could do was edit hollow objects, right? And if you tried to bring a solid object in, if you've ever worked with a Sirona model, it'll have it completely watertight, and if you try to bring it in, it'll throw an error at you. With Copy Denture, you're able to edit solid objects in 3shape. So it's also a great method if you're doing reference dentures, doing like CBCT markers or fiduciary markers for implant-guided surgeries. So Copy Denture, as the name suggests, you're scanning it in, upper and lower side of the denture, and you're aligning it to make a nice solid object. So in my example that I was telling you, where the patient loves their existing denture, or maybe they need to do a little reline or a rebase or something like that, but they want new teeth, you could go into Copy Denture, you could take this and you could manually try to, again, carve chicken scratch, as I was saying, and designing it and trying to make it look somewhat presentable. But the sculpt tools in 3shape aren't very hard and they aren't very defined, so often what you need to do is it'll end up kind of averaging, or it'll modify your occlusion, right? The nice thing about Copy Denture, though, is you're able to choose these teeth, create segments with them so you can have tooth-colored teeth, and then you could mill out or print out denture-based colored base. So in my example, instead of using the Copy Denture module, what I'll do is I'll still scan it in with Copy Denture, but then temporary unprepared model, my favorite indication, we'll go ahead, select all these teeth here, temporary unprepared model, 14 teeth, bridge it all together, again, to save us some time. On this example, it is an upper and lower complete denture where the patient loves the fit. They've had it adjusted a million times, so there's no sore spots. They've lived with it for 10 years, but the teeth are discolored. They're stained, but they want new teeth. So what do? Temporary unprepared model allows us to add those Pontics irrespective of anything else. right? So we can go ahead, focus on the design, focus on the occlusion. I'm going here, tweaking things as I need to. And we just go through, make sure that we have a nice looking design for them. You can bring in full face photos, you can bring in face scans, you can check everything like that. And I'm just kind of working on each arch individually, and it's like a very free form editing of this. Right? So once I get to a point where I'm like, okay, I'm pretty happy, these teeth are kind of poking through, we're gonna go back and we're gonna modify our denture base next. So once I'm done with the design, and the nice thing is you're only really designing half of an arch, right? And then you can mirror it and copy it to the other side. So now I go ahead, remove these teeth, and this is in the prepare step here, right? So remove teeth, and that allows me to check my occlusal vertical, like occlusal contacts, adjust anything that I may need to at that point. And what I'll do is I'll go in there, select all these teeth, and save them as an additional scan, if I forget to that point there. And you'll really appreciate this if you use the denture teeth module. You don't have a lot of these tools. So if you're familiar with crown and bridge tools in 3shape, you don't have, there's a lot of limitations there. But what I'm doing now is I grab those files that I've made and I'll bring them back in and I'll align them and I'll use those to check my clearance, sculpt the denture base as needed, adjust the occlusion again. And for me, I don't like that they don't have like a sculpt tool like this, even if you use a designed indication in the denture module. So I like having the ability to use some of my add and remove smooth tools. So now we're saving these upper, lower. And we can remove anything, sculpt the denture base, wax up the denture base using this prep tool. So we're really moving back and forth, and it's really free form, right? It's not like you're moving in a linear fashion. You can see here I need to remove these underneath as well. Now what I do is I'll control click, select the files, I'll combine them, and then I'll bring them into Mesh Mixer. And the reason I do this is you want to make sure that they're solid. So you just want to make these objects solid and printable. You can typically throw these into your printer right away, but it might throw you an error, it might print out some flat lines that don't show up and give you some artifacts. So we'll just drag these in, and these are our monoblock try-ins that we'll send to the doctor. And then once they're happy with that, if they make any adjustments, we can scan these back in again with Copy Denture, segment these teeth, mill out the teeth in 3 segments, and mill the base out. So I'll leave you with one kind of final analogy here. A lot of you, I'm sure, are familiar with Super Mario. It's a pretty famous video game, and the premise is pretty simple. Mario goes from left to right across the screen, jumping over objects, collecting mushrooms and all these other power-ups and coins, until he gets to the end of the stage where he slides down the flagpole. And that's a linear game, right? It's a platformer. I'm sure you're also familiar with another famous franchise, Grand Theft Auto. Grand Theft Auto is what they call an open world sandbox type of game, right? So you can go do the missions, you can do side missions, go bowling with your cousin, fly airplanes, do races, play online games with your friends. And this open world sandbox is very much like a child in a sandbox. They play in there, they can go at their own pace, and as long as they stay inside the sandbox and follow the rules in there. So with 3shape, when we're taking on these kind of advanced workflows, these complex workflows, we really want to stop playing Mario with 3shape. It's a very good, it's designed for that. It's very linear, it allows you to produce. If you follow those indications, that's kind of why it's a testament to its success as a CAD program. But if you're kind of in the edge cases where I spend most of my time, you really do want to play Grand Theft Auto more, right? So you want to, as you saw in my previous design there, I designed the teeth, went back, sculpted the denture base, removed the teeth, go forward, add a scan, and so on and so forth until I found my final product that I was happy with. So just in summary, we have some of these topics that we covered today. Temp on prepared model. Don't get hung up on the name that it's a temporary unprepared model. It's more of a free-form sandbox designer. The Copy Denture scan or the Copy Denture module as a whole is not just for copying dentures. It's a solid object editor. You can bring it in, you can edit your objects, whatever you may want to edit. The additional scans tool is great for exporting, saving things, combining all these objects. And of course, we didn't cover this, laundering DCM files for anatomy for use. But if you are interested, like I said, dentaltechtips@gmail.com, send me an email. I'll add you to my mailing list when we confirm the date for that hands-on course, and we'll show you how to do that one. And then, of course, Windows Explorer, renaming files, anatomy for use, modifying scans, changing things around so that the software lets you do what you want to do with it. So I know I threw a whole bunch of different topics, and I could probably give 2-day courses on each one of these topics, but hopefully I provided you with some information to really whet your appetite for working with complex cases and kind of thinking outside the box. And with that, if you do want to continue the conversation online, do like me, follow me, send me an email. I'm more than happy to answer any questions, Dental Tech Tips, and thank you. Any questions? Yeah. Thanks. Code. Everybody's sitting here patiently. Our course code is 824. How are you? 824. You'll probably get something for you. I don't know. Maybe look at it. Yeah. All right, Jerry, see you, buddy. Okay, guys, I'm gonna go. Yes, we do online and we do in person. Yeah. Okay, for sure. Absolutely, for sure. Support. So the reason for that is using the hinge articulator check? I use the metal hinge. Yeah. That's your problem. Well, I use, what do you mean? We use, we have a tooth and with the pen. Yeah, you can use that to check it. Right. But the mounting has to be exactly the same in the CAD software as it is on the model. Yeah, because I have a hard time using using it's called the vertical. Yes. The 3D articulator. Yes, it is. Digital articulator to where the conventional analog. Yeah. So what I do there, we had the same problem. We printed 2 of the neck guards, right? And it costs you a little bit of money. Yeah. We print 2, but you take one, you give it to the technician, they finish it on the bench. You take the other one straight out, remove the support, and just polish. label number one, number two, send it to the dentist, and say which one do you like better. The one that wasn't adjusted, or the one that was adjusted. And I guarantee you the one that just came straight from the printer is the one that they're going to like.
We're gonna try that.
Try it.
We have printed, and then this is what we get the model.
So he does on-site.
We articulate the models,
Yep.
open the bite, 2 millimeters. Okay, now we scan the models. Okay, we open the 2 millimeters
Instead he
in
does
the
like on-site
virtual
stuff.
articulator, and then we design the eye guard, the printer comes out, it fits in the model, and when you close
When
it.
you close it, it's on the back is open like this, and then on the front, or one or the other.
Right, one or the other, depends on whatever they want. And then there's the grind. We, I'm in that stage where I
And like he
trust
sends
the
you.
analog.
Oh, no.
Trust the design. I tell you, we've done thousands of this.
He's
So
really good.
I still believe that I'm doing either somewhere is a step that I'm using,
Yeah.
I wanna
Like he makes
how
you
to
do like
do it wrong that they don't,
and then like your
they don't
body
match.
is
They don't match,
silly,
yeah.
like takes pictures.
See, the articulation,
Like,
the
it's
position
really
in the
good at
articulation, if you change it 1 degree, it changes everything. Right? So if you think like a small articulator like this versus like this, it moves different. It moves very different, and the patient moves completely different too. So
But I will try this print too, one just the analog way,
do both.
and then the
Do
other
it for a
one.
couple doctors that you're
Yeah.
close with, and just say,
Yeah,
hey,
yeah.
try it.
Try it.
Keep both. Let the patient have both. No charge, right?
Just let me know which one.
Let me know which one's good. I guarantee you the one that you design is that they're gonna love.
Right, but I will be in touch with you. Thank you.
Absolutely, for sure. Hey, you're much taller than I thought you'd be. Oh, okay.
I've tried your method for the copy denture, getting new teeth.
Yes.
Have you been able to get CAM 5 files after?
No, you want to do live motion? Is that why? I was
I
thinking
mean,
about
I
that.
have to, but I can't, I've tried everything I can to get the CAM 5 file.
No, because it doesn't have the ribbon. That's the whole point.
Yeah.
I
No,
wonder
but
if you could.
not even for the eye motion. I just want regular CAM 5.
Yeah,
Like,
yeah.
because when I bring it back into copy denture, it errors out unless I do it as
Yeah,
STL.
yeah. It has to be STL.
I was wondering if it was myself.
No. So Cam 5 is like
It's annoying.
It's based off of like something inside of PCM,
Yeah.
actually.
Because I can do CAM 5 on regular copy denture.
Yep.
But for some reason, if I save this, even if I run it through Meshmixer and then I import it and then I try to run this copy denture, it doesn't let. Oh, I just had a thought. I could just print it.
Print it, bring it
And
in.
make it a
in
file.
Cam 5, try that.
I'm gonna try that.
Try
Got it
that.
right down. It just came to me.
So hopefully you learned something. I mean, you know your stuff.
Those are good tips. And like, yeah, very good.
Thank you.
Legally back. I only design dentures, so all of this like tampon prepared is like new-ish. Like,
Yeah.
I only design forms or dentures. So this is very helpful.
It's very powerful in the fact that if you want to do some kind of weird thing.
Yeah,
So.
it helps me with a lot of things. I'm gonna try some new things. This was great. Thank you.
Thank you.
Sitting
And
back
next
there
time,
like
too.
all excited.
Yeah, I'm like, ooh, new things.